In this video, we are going to go over how to solve multi-step inequalities. These steps, again, should look familiar because we are using essentially the same steps that we used when we solved equations. Step 1, we're going to combine like terms if there are any. Step 2, identify the variable we are trying to solve for. Step 3, identify what is preventing that variable from being by itself, and we have to determine what operation is needed to undo it. Step 4, perform that operation. Step 5, we're going to repeat steps 2 through 4 until the variable is alone on one side of the inequality. Once we've completed step 5, we are ready for our last step, which is to graph our final answer. Let's look at an example. In this example, we have negative 2r plus 3 is less than or equal to negative 10. First thing that should stand out is we have a plus 3 and a plus 3. These two things can be combined together with addition, so we have a negative 2r plus 6 is less than or equal to negative 10. Now this looks like a two-step problem, and we can use our steps from previously if we remember them, or we can continue to follow the steps that we were at, which is now we need to identify what are we trying to solve for. Well, I'm trying to solve for that r. What's preventing him from being by itself is that plus 6 and that times negative 2. We need to deal with that plus 6 first, so we would need to undo that by using subtraction. So we're going to subtract 6 on both sides. That gives us a negative 2r. A 6 minus 6 gives us 0 and cancels out. And a negative 10 minus 6 gives us a negative 16. We are still trying to solve for r, so we need to divide both sides by negative 2. When you divide an inequality by a negative number, you're going to change the direction of your inequality. Negative 2 divided by negative 2 cancels, leaving us with just r, and negative 16 divided by negative 2 gives us an 8. So we now have r is greater than or equal to 8. We are now ready to graph. We need to figure out, do we need an open or a closed circle? We have the or equals to part of our inequality, so that means we're going to need a closed circle at 8. So I'm going to go ahead and put that there. And now we need to figure out which direction to draw our line. We want all of the numbers that are greater than 8. So we're going to go over here to the right, and we can color in our line and draw our arrow because it does go on forever. And we have completed example number 1. Let's look at another problem. In this problem, we have a 4m minus 4 plus 7 is greater than or equal to negative 9. So again, the first thing that should be standing out is we have a negative 4 and a plus 7 that we can combine those like terms. So we have a 4m, negative 4 plus 7 combines to give us a plus 3. We still have the greater than or equal to negative 9. Now we need to get rid of that plus 3, so we're going to subtract 3 on both sides. That's going to leave us with a 4m plus 3 minus 3 gives us 0, canceling out. And negative 9 minus 3 gives us a negative 12. We still do not have the m by itself, so now we need to undo that times 4 by dividing by 4. We're dividing by a positive number, so our inequality is going to stay the same. We don't need to change it. 4 divided by 4 gives us 1, canceling out, leaving us with m on the left is greater than or equal to negative 12 divided by 4, which is negative 3. So now we're ready to go ahead and draw our graph. So we need to figure out, do we need an open or a closed circle? Well, it has the or equals to part of the inequality, so that tells me a closed circle at negative 3. So I'm going to go ahead and fill that in up here on the graph. And now we need to determine which way we need to draw our line. We want everything greater than that. Well, greater is going to be over here to the right. So we can go ahead and draw our line. Don't forget to put your arrow at the end, indicating that it does go on past where our line is drawn. And we've answered example number 2. Let's look at a third example. This one is a little bit different, but the process is still the same. Negative 24 is greater than or equal to negative 2n plus 5n. We still have like terms that we can combine. So we have a negative 24 is greater than or equal to the negative 2n plus 5n combines together to give us a 3n. Now we need to still look to see what is preventing our n from being by itself. It's that times 3. We undo multiplication with division, so we're going to need to divide both sides by 3. Over here on the left, we have a negative 24 divided by 3, which gives us a negative 8. We divided by a positive, so we just leave our inequality the same. 3 divided by 3 is 1, canceling out, leaving us on the right with just an n. So we have negative 8 is greater than or equal to n. When it comes to graphing, it's always easier to graph when our variable is on the left. So I'm going to read this inequality backwards and write it down. So n is less than or equal to negative 8. Now from here, I can graph much easier. We need to know open or closed circle. Well, it still has the or equals to part, so we're going to need another closed circle at negative 8. So I'm going to go ahead and fill that in up here on our graph. And we need to know what side of that dot is less than. Well, that'd be over here to the left, because we wanted n is less than. Everything less than that circle goes over here to the left. Don't forget to draw your arrow, and you have answered example number 3. Let's look at a fourth example. Here we have 165 is greater than negative 3 times, in parentheses, 1 plus 8n. So first thing, all we have is something times the parentheses and nothing else attached to it in any way, so we can go ahead and take care of that times negative 3 first. So we're going to divide both sides by negative 3. When you divide by a negative number, you need to switch the direction of your inequality. So I'm going to do that right now before we forget. 165 divided by negative 3 gives us a negative 55. Is less than, negative 3 divided by negative 3 is going to cancel, leaving us with what was in the parentheses, and we no longer need them. So now we have negative 55 is less than 1 plus 8n. So now we continue our process to solve for n. I need to subtract 1 on both sides. That's going to give us a negative 56 is less than 8n. And now we need to deal with that 8 times n. So we'd undo multiplication with division. I did not divide by a negative, so my inequality is going to stay facing the same direction. Negative 56 divided by 8 gives us a negative 7. 8 divided by 8 gives us a 1, canceling out, leaving us with just the n. And again, it's easier to graph when our variable's on the left, so I'm going to read this inequality backwards. So that is n is greater than negative 7. And now I can go ahead and draw our graph. We need an open circle this time because we do not have the or equals part of our inequality. So at negative 7, I'm going to draw an open circle. Go ahead and put that up there on the graph. And we want everything that is greater than. So greater than is going to be over here to the right. We can go ahead and fill in our line. Use up the entire number line that is provided for you. And don't forget to draw your arrow. So now we've solved example number 4. Let's look at another one. Here we have 169 is greater than x plus 7 times, in parentheses, 1 minus 4x. This one is slightly different because we have this x attached out here, so we can't just divide both sides by 7 yet. So what we're going to do, instead of dividing it, we're going to have to distribute to get rid of the parentheses. So we have a 169 is greater than our x. 7 times 1 is 7. 7 times negative 4 is a negative 28x. Now we can look to combine like terms. So that x minus the 28x, we have a 169 is greater than the 7 minus 27x. Now we need to get rid of that 7, so we're going to subtract 7 on both sides. So it's going to give us a 162 is greater than 7 minus 7 is going to cancel out, and we're left with our minus 27x. Now we need to get the x by itself, so we're going to need to divide both sides by negative 27. We did divide by a negative, so we're going to need to change the direction of our inequality. I'm going to move over here so we have more room. 162 divided by negative 27 is going to give us a negative 6. We now have less than negative 27 divided by negative 27 cancels out, leaving us with just our x. So we have our solution. Again, it's easier to graph when our variables are on the left, so I'm going to read this inequality backwards. So we have an x is greater than negative 6. We need an open circle because we do not have the or equals to part, so I'm going to find negative 6 on the graph and put my open circle. Now all that is left is figuring out what side to shade. Well, we want everything that is greater than or larger than negative 6. That's going to be over here to the right. And we've solved another example. Let's look at one final example. Here we have negative 246 is less than 6 times, in parentheses, negative 5 minus 6p. Since there's nothing else besides the parentheses and what it's multiplied by, I can go ahead and undo that right now using division. So I'm going to divide both sides by 6. I didn't divide by a negative, so my inequality is going to stay facing the same direction. Negative 246 divided by 6 gives us a negative 41 is less than. 6 divided by 6 cancels, gives us 1, leaving us with just what was in the parentheses, and we no longer need those parentheses. We're still trying to solve for p, so we undo that minus 5 by adding 5 to both sides. That's going to give us a negative 36 is less than negative 6p, and we can undo that times negative 6 by dividing both sides by negative 6. In this case, we did divide by a negative number, so we would need to switch the direction of our inequality. I'm going to move over here to the side so we have more room. Negative 36 divided by negative 6 is going to give us a 6. Negative 6 divided by negative 6 gives us 1, leaving us with just a p over there on the right. Again, it's easier to graph when we have the variable on the left, so I'm going to read this inequality backwards. We have a p, and then it's less than 6. So now we can go ahead and draw our graph. We need an open circle at 6, so I'm going to go ahead and draw that, and we need to figure out which way do we need to draw our line. We want the numbers that are less than, so that's going to be over here to the left. Don't forget to draw your little arrow because it does continue to go on past where our number line is drawn. And we've now solved our 6th example. Hopefully this video helped you to understand how to solve multi-step inequalities and graph them. As always, if you have questions, don't hesitate to ask me in class.